Introduction to Chapter 2.1 Transformation of Quadratic Functions. Essential question: how do the constant a, h, and k affect the graph of the quadratic function? Gx equals ax minus h squared plus k. So this is the same type of equations that we have used for absolute value function, but without the square. Instead of this bracket and square, we had two parallel lines for absolute value function. But we moved the graph in the same way. So this is for moving left and right, and k was to move from up and down. So in this case, the parent function of the quadratic family is this one, fx equals x squared. A transformation of the graph of the parent function is represented by gx equals ax minus h squared plus k, where a is not equals 0. So anything without any number, so for example, no a, h, or k, just a simple function starting from 0, 0 from the vertex is called parent function. Whenever we add something to it, like a, which is used for vertical stretch and shrink, h for use horizontal left and right translation, k is used for vertical translation up or down. So this type of a function is used for translated function. So we call it as translated function. So exploration: identify graphs of quadratic function. Match each quadratic function with its graph. Explain your reasoning. So these are a few equations of the graph. And if you look at the bottom of this worksheet, you will see few graphs, and then you're going to match the graphs with the equation given above. So right now I'm going to give you the time to explore and write down the or match the graph with the equations, and then we'll go over on this together. So the first one is gx equals negative x minus 2 squared. So the negative in the front means that it's a reflection over the x-axis, and inside 2, if it's negative, you're going to go to the right 2. And if you look at these graphs, the only option that is moved 2 units to the right and is upside down, which is a reflection, is letter D. So my answer is going to be letter D for A. The next is gx equals x minus 2 squared plus 2, which means that this 2 inside means you're going to move right 2 units, and for outside 2 means that you're going to go up 2 units. And out of these graph that matches with the right 2 up 2 from the center is C graph. So from the center is moved 2 units to the right and 2 units up. So it's going to be letter C. For letter C, gx equals negative x plus 2 square minus 2. So this negative outside means that it's a reflection over x-axis, and this plus 2 means that it's left 2 units. Outside you have a negative 2, which is k, and then you're going to move this graph down 2 units. So the graph that matches with this equation is going to be letter A, that is moved 2 units to the left and 2 units down, and it's reflected. It's upside down. So that's going to be your A graph. For D equation, gx equals 0.5 x minus 2 square minus 2. If this number A is less than 1, in this case it's less than 1, then it's going to be a vertical shrink. So it's a vertical shrink by a factor of 0.5 or 1 over 2. And the negative 2 inside means it's right 2 units. Outside k means that it's going to be down 2 units. And the graph that matches with this equation is going to be your f graph that is starting from 2 right and 2 down, and here is going to be your first point is this one that shows that is a vertical shrink by half, so it's going to be your f graph. Now let's discuss gx equals 2 times x minus 2 square. So 2 outside in the front means that is a vertical stretch by factor of 2, and the negative 2 here inside it means that it's right 2 units. And the graph that matches with this equation is going to be your graph that is B graph, that is right 2 unit, and you can see that this is a skinnier graph, so it's stretched graph by factor of 2. So the answer for this equation is the graph B. The next question is gx equals negative x plus 2 square plus 2. So the negative in the front means that it's a reflection, plus 2 inside means that it's a left 2 units, and outside 2 is compared with k, so it means up 2 units. So left 2 and up 2, this means that is this graph right here, so left 2 unit and up 2 unit, and where you reach this point then you're going to have a reflected graph, so that's going to be your E graph for this equation. Now let's discuss number 2. How do the constant a, h, and k affect the graph of the quadratic function gx equals a times x minus h squared plus k? So this a is used for vertical shrink and stretch. It is vertical stretch if a is greater than 1, and it is a vertical shrink if a is less than 1. For the h inside, if it is plus h inside, then you're going to move left h units, and if it is negative h, then you're going to move h units to the right. For k is used for vertical translation, up or down. So if it is plus k in this case, then it's going to be moved up k unit, and if it is negative k, then you're going to move the graph down k unit. For number 3, write the equation of the quadratic function whose graph is shown here. Explain your reasoning. So our standard form of the equation of for quadratic function is y equals a x minus h squared plus k. So what we need to do is to find a, find h, and k. H and k is the vertex, which means where the parabola starts or where the graph starts. So this point right here is going to be your vertex point. So we need to figure out what is this point. So it looks like this point is going to be 1 comma negative 2. So this vertex is 1 comma negative 2. It means that we found the h and k. Now we have to figure out the a. So the normal pattern for the graph is up 1 over 1 if it is a parent graph and there is no vertical stretch or shrink. Then it rise by 1 up, 3 up, and 5 up. In this case, we can see what is the next point after negative 2. So it's rising up 1 and over 1. So the next point is this one. It doesn't look like that this one is a vertical stretch or a shrink because it's going to be going up 1 over 1, and that is the normal pattern for your parent graph without any vertical stretch or shrink. So a is going to be just 1. So now you are going to plug it in values that you just found, which is a as 1, x minus h is 1, and then k is negative 2. The equation of this graph is going to be y equals x minus 1 square minus 2.